Okay, how you guys doing? All right, we're starting chapter 3, which is the start of the material for the next exam. So the story, what we're going to talk about is a lot of the stuff that relates to ecology in this chapter. And when you talk about ecology, you sort of need to understand where everything begins. And so we start out our chapter with a discussion of someone that everyone has heard of, and a theory that he put forth that a lot of people don't understand because there's a lot of misinformation out about it. And of course, who I'm talking about is Charles Darwin. Charles Darwin was a rich guy. He was a rich guy in England. So he had a lot of money. He didn't have to work, but he was interested in nature. And so one thing that sometimes rich people would do is they would go aboard some kind of a government sailing ship as an unpaid passenger and act as a naturalist, because the ship was going out into the world, and as it went wherever it was going to do its job, the naturalist would study the world around him. And the reason that they had this kind of an arrangement is the captain of ships, back in those days in particular, was really over everybody. He was the law. And in order to have a companion, if he had a gentleman, someone, with money on board, they could eat dinner and have interesting discussions, and he could still maintain his position of power over everyone on the ship. And that's what Charles Darwin did. And he was aboard a ship called the HMS Beagle. And what this ship was doing, it was doing a very boring, laborious process where it would go along and they would drop a line down to the bottom of the ocean. And they had marks on the line, and they'd say, okay, we're in however many fathoms of water. And then they'd go a little ways down and they'd do it again. And they'd go a little further down and they'd do it again. And they'd do this repeatedly over and over again all day long. They were surveying how deep the ocean was in various locations, including Central and South America and the islands offshore, the Galapagos Islands. Okay, so that's what Charles Darwin was doing, and he had lots of time on his hands, and he was very interested in it. So he was looking at the birds and animals and things in all of these different locations. And they had done this survey off the coast of Ecuador, and then they went out to sea to a group of islands called the Galapagos Islands. And so he looked at the birds and stuff in Ecuador, and he looked at the birds and things in the Galapagos Islands. And he said, wow, look at that. These birds that we have out here on this island, they remind me of the ones that we saw in Ecuador, but they're really different also. And it wasn't just go look at them with binoculars. They would actually go and kill a whole bunch of birds, and so they had them looking at them and could carefully examine these birds. And ultimately, this experience was used with some thinking about some material he had read to develop, eventually, after about 20 years, to develop the theory of evolution. And I said, so everyone's heard of Charles Darwin, and they've all heard of the theory of evolution, but immediately you always get these crazy things, and so crazy ideas, misinformation about how it works and what it is. And so what we're going to do today is I'm going to talk, and in future classes, we're going to talk and explain this whole process. So what was on Charles Darwin's mind prior to looking at these birds? What he had been reading is an essay by someone called Malthus. And Malthus noticed something in the world. He noticed that we produce more offspring than can survive. And this is kind of across everything. He realized that there's always this excess of offspring. Now, one of the things that Darwin didn't know about, but we had some understanding of, was about genes and chromosomes and all of this stuff. But long about the same time that he was thinking about all this stuff, that we were starting to develop an idea that there was some kind of inheritance substance. And so Charles Darwin was thinking about the Malthus essay and looking at the stuff that he was finding, and he came up with this idea. And so we have some criteria that go along with the theory of evolution. One of them is that there is an excess of offspring. There's only so much food out there and resources, food and other resources out there. And so that is limiting, and you've got more babies than can survive. The second important point in all of this is that the traits that we're talking about have to be genetically derived. They have to be coded for in the genes. And so you have a variety of genes in the offspring. Even if you have, the same mother and father, you get a mixture of genes, half of the genes of the mom and half of the genes of the father, but it's all random which ones you get. And so the second point is you have to have genetically derived traits. And then you have competition. And so, maybe you've seen these nature shows, right? And they show kind of heartbreaking situations where the mama is bringing food to the baby birds, and there's one older one. What happens with the birds is they lay an egg every day. And of course, the one that was laid first is born first, and then a day later, the second one, and a day later, the third one. And so, they're stair steps, big, medium, little. And then you start competing for food. Mom's got a mouse, going to give it to the baby eagle. And who's going to get it? Well, you got the big one going in there and shoving the others aside and getting most of the food, unless it's full, right? And so then when it's full, then the next one gets some. And then if you have a really good year where there's so many mice that there's no real problem, then the little one gets it. But in many circumstances, the first one and maybe the second one survive, but that littlest one dies. And so we have competition. So we said you have an excess of offspring, you have genetically derived characteristics, and you have competition for limiting resources. And as a result of that, the individuals who, after they get bigger, you've got these two, we'll just sort of follow through with that story. The two individuals, but maybe the one that was the second one, maybe he has extra long feathers. And so when it comes time to fly, he can fly really fast. And so he is actually the most fit of those two. And so that would be a genetically derived trait that I'm talking about. And so you have survival of the fittest. Years ago, when I started teaching this class, Mark Spitz was an Olympic swimmer. And if you've ever seen him, he's like this tall, skinny guy with really long arms and legs. And he's like perfectly built for swimming. And I used to talk about how if we had Water World and, and everyone had to swim from one location to another, he'd get all the babes, right? So we have these characteristics, as we said, excess offspring, genetically derived competition, survival of the fittest, and reproduction. That's the key to it. So in the case of Michael Spitz, he'd get all the babes. He'd have all of the babies. And so what would happen in the population if we went from a land-based world to a water-based world? Well, maybe his genes would be kind of rare, tall, skinny dude with long legs and arms. Maybe that would be really rare in the population. But in the water world scenario, he could swim laps around everybody else. And so his gene frequency, the genes that code for long arms and legs, would increase in the population. That is what happens in evolution. It isn't about the individual. It's about the population. So you would go from strong, burly men to the skinny dudes, right? And so you would change the gene frequency as a part of the adaptation, the evolutionary forces, water world, the forces it has on the population. Has nothing to do with the individual, except some die and some survive, and there's different levels of reproduction. But the forces of evolution occur on populations. Okay, so that, pay attention to this particular discussion, because there are those four criteria and that we had mentioned that go into the theory of evolution, and you have to realize it's all about differential survival plus having babies. That's the most important point, is if you have the best genes, then you have more babies, then your gene frequencies, the number of genes that you contribute to the population increases. All right, I'm going to stop right here. Chapter 1, or slide 1 only. Wow. Okay. We'll be back in a minute.